we're going to take a look at dimensional analysis. This is the most important portion of the chapter. And this is kind of one of those things that you really need to understand moving forward because we constantly use this. And the assumption is you know how to do this moving forward. So you already do this kind of stuff on a regular basis. You already understand how to do dimensional analysis. It's just a matter of using it in a mathematical context and not just figuring it out in your brain because it's going to get much more complex. So, if you wanted to make a grilled cheese sandwich, what's the formula for making a grilled cheese sandwich? Okay, so certainly we're going to need 2 slices of bread because no one's going to use more slices of bread than that. So I'm going to write a formula for this. 2 slices of bread. That's my best attempt at drawing a bread. Plus, I want to make the numbers not really simple. So let's say we really want something cheesy. So we're going to say 3 pieces of cheese. This is my best attempt. And we're going to put some holes in it. We'll pretend it's Swiss. There's my my grilled cheese sandwich. 2 slices of bread, 3 pieces of cheese, and we can actually add anything else we want. And how about we add even one uh, one little tablespoon, or yeah, sure, we'll go for it. 1 tablespoon of butter is going to make us a delicious, one delicious grilled cheese sandwich. Okay, so we have the ratios for this. We have the ratios, the fact that it's 2 slices of bread to 1 slice of cheese. These are all conversion factors. I know that the ratio of sandwiches to bread for every 2 sandwiches or 2 slices of bread, I can make 1 sandwich. That's a conversion factor because 2 slices of bread per 1 sandwich, or 3 slices of cheese per 1 sandwich, or 2 slices of bread versus 3 slices of cheese. So these are all conversions within this context of this formula of this recipe. Okay. So if I have 10 slices of bread, okay, how many sandwiches can I make? So right off the top of your head, you're just like, oh, well, 10 slices of bread, two, 10 divided by 2, because that's how many slices is going to make me 5 sandwiches. But let's put it into mathematics here. So if I have 10 slices of bread times fraction, I want the bread to go away and I want the sandwiches to remain. I'm just going to put sandwiches. Okay. What I know from my formula is 2 slices of bread for every 1 sandwich, right? So that's the ratio of those two. But instead of thinking it in your head, which we already know, we can simply plug this in a math context because my bread is going to cancel and my remaining unit is going to be sandwiches. 10 divided by 2 should end up with 5 sandwiches, which makes total sense in the context of, well, yeah, that's what we said at the beginning. Why did we have to do this? Well, things can get more and more complicated. So we want to make sure that we take advantage of that. So how about this next one? All right, well, 5 slices of cheese. Again, times fraction. I want the cheese to go away. And I want to figure out how many sandwiches it's going to make. For every 1 sandwich, I'm going to have 3 slices of cheese. So the cheese cancels, and I'm going to have how many sandwiches? Well, 5/3 or 1 2/3. Oh, blue. There we go. 1 2/3 sandwiches. So I can almost make 2 sandwiches, but technically I can make 1 2/3 sandwiches. So again, we're doing this math and it's going to give us the ratio of our answer just by simply doing a conversion. Again, these are all conversion factors. Just any one that you want to set up. And we can put these in any order that we want. What happens if we start with some other random thing? Like, whoa, what happens if you have 3 loaves of bread? Well, if I have 3 loaves, and I know first thing I want to do is multiply fraction. A loaf of bread has how many slices? And I said bread before, so I'll do it here again. one loaf is equivalent to 13 slices. So again, instead of me just what you would normally do is in your head, you would say, well, I have 3 loaves times 13. That gives me, what is that, 39. So immediately in your head, that's the math that you would do. But we don't need to do that because we have conversion factors. So at this point, I would stop. You would normally do this in your head, like in an everyday basis. And then we're going to move along again because I want to get to sandwiches. I don't care about how much bread we have. I want the bread to go away, and I want to end up with sandwiches. One sandwich is 2 slices of bread. Bread cancels, and I'm left with how many sandwiches. So we're just simply going to do that math at this point where I'm multiplying. So 3 times 13, right, divided by 2 gives me 19.5 sandwiches. Again, doing that process in our head. Okay. So again, we do this stuff every day. When we're given a list of conversion factors like this, we have to use those as we proceed through these problems. This is dimensional analysis. This is simply using the information in a problem to figure out some other information that has different units. So with that, we're going to do this in class. This is one of my favorite examples to do. So what does it cost to you to go to school per class session? So we're going to talk about this in class because it's a really good kind of setup for this. And then moving on to this, a recipe calls for 1.25 cups of flour, 150 grams of sugar, 0.5 cups of butter in order to make 12 cupcakes. So if we can write this out, but we know that every single one of these is a conversion factor. So we know that for 1.25 cups of flour, I'm going to need 150 grams of sugar. So those are equivalent to one another. I know I need a half a cup of butter. Those are equivalent to one another, and 12 cupcakes. So we can start with any one of these and we can convert to the other. For example, how much sugar do you need to make 50 cupcakes? Well, again, we start with the number that we need, all right, so or that we have. We are looking for 50 cupcakes. I'll just do CC. We need 50 cupcakes. So times fraction, I always want the unit that I have to go away. So I'm going to put it opposite. I want cupcakes to go away, and I am looking for sugar. So according to my list above, 12 cupcakes is equivalent to 150 grams of sugar. Cupcakes is going to cancel, and I am going to be left with a certain amount of sugar for this, okay? So sugar. And so now I just do the math. And how I would do this math, by the way, the way that you're going to do this math is I'm going to take 50 times 150. We'll multiply the top, enter. So I'm going to enter that. So that's taken care of, 50 times 150, and then divide that answer by 12, enter. I'm going to need 625 grams of sugar. There's my answer. So in order to make 50 cupcakes, I need 625 grams of sugar. Okay. All right. So with that said, what happens if you only have 5 cups of flour? How much sugar do you need? How many cupcakes does that make? So again, we can do multiple conversions. We can kind of look at this in this idea of setting it up based on the units that we have. Problems like this. The trip from New York City to Miami is 2,075 kilometers. How long would it take if you traveled 65 miles per hour? So you have a speed limit or a speed per hour. This right here means it's a conversion because it's 65 miles per 1 hour. And we have another conversion here because miles and kilometers are equivalent. We're going to talk about those as well. And so that's the idea. And then the last little bit. These seem much more complicated than they are, but conversions involving volumes. So inches to centimeters cubed. We don't know this. There is no simple conversion for that, but I can look up something like this, inches to centimeters. So you're given this value. Well, instead of doing this in line, we're going to set this unit up ahead of time. So I'm going to take 1 inch is equivalent to 2.54 centimeters. And now I'm going to cube both of these. because I want to get the unit set up. I want to get that conversion factor set up ahead of time. When you're cubing something, first we're going to do the number, so 1 cubed, and then we're going to take inches cubed. So this turns out to be 1 inch cubed. That's easy. So the next one, I'm going to cube both. I'm going to cube the number, 2.54 cubed, centimeters cubed. So now I just need to do 2.54 cubed. What do I get? 1 inch cubed. So if I take this value and I take a look at 2.54 cubed, I end up with 16.4 centimeters cubed. Now that I have the conversion factor, I can now do that conversion. So I'm going to write that out and solve for it. So how many cubic centimeters do you have from that? Converting these units, liters to meters cubed. Again, there's 2 that we need to know. So 1 decimeter cubed is equal to 1 liter. But the one we use more frequently is 1 centimeter cubed is equal to 1 milliliter. So think about how you would solve that, and we can talk about it in class. All right. So with that said, we're going to talk about density and temperature to finish this up, but that is dimensional analysis. You must know this, really important that you do.